All right, let's get started. Welcome everyone. This is gonna be the part two of the electrical series. I don't know how many of you have already done part one, so if at any point you uh, feel lost or want to ask, uh, stop me and I'll try to clarify. Um, The first part is going to be a quick review of a few concepts that you need to know before we move on. And then we are going to talk about a few of measurements that you can do in the lab, um, things that you can measure like current and voltage, and what equipment do you have in the lab to do that. Unfortunately, due to COVID, we are not allowed to do it in the lab. So instead, we're going to be using a online tool called Tinkercad that I hope some of you might be familiar with, as is was used in the first part of this series. So let's start with a quick review. So I hope you are all familiar at this point with passive components such as the resistor. Um, the idea of the resistor is that opposed to the flow of the current, and it's going to have a certain voltage depending on how much resistance it has. A few properties when you're looking at equivalent systems. For example, if you have on the left a series, a group of resistors connected in series, which means like one connected to the end of the other one, and so on. Um, if we were to replace all of them for an equivalent resistor, we just need to sum the value of the resistors. Um, if we were to have it in a different configuration as the one on the right, which is called a parallel configuration, the equation is slightly different, and we can see is the sum of the 1 over the value of the resistor. Hopefully that's familiar for most people. Next, so the idea of current is that we're looking at how fast are electrons moving through the cables. In this case, the convention is that while the electrons are moving in one direction, we say the current, the electrical current, is moving the opposite direction. And that convention established that the we will say the plus or the larger voltage, which I'm going to talk in a minute, is on to, towards where the electrons are flowing. Therefore, the current is coming from that direction into the place with a lower voltage. And the unit for measuring current is called ampere, and then we use an A for that. So the voltage, think of how much force or like the force you need to move those electrons. So if you have a high voltage, you're going to be able to move a large amount of current. But if you have a low current, low voltage, then the current that you're going to be able to move is going to be much smaller. And the units we use for voltage is volt. So as we can see here, we have on one end the voltage which we're pushing the electrodes to produce a current, and then we will have some elements like a resistor opposing resistance to the movement of the electrons. And the way they relate to each other is that the amount of current that is generated based on the voltage they are gonna be proportional to each other. And then we have Ohm's law that tell us what that relationship is. So in this case, when we apply a voltage to a resistor, we will have a certain current, and the voltage generated by that current circulating through the resistor is going to be equal to the multiplication between the current and the value of the resistor. As you work in the lab and you're going to be interacting with different equipment, there are a series of measuring tools that you have access to. For example, you can use a multimeter that allows you to do different measurements. For example, you can measure voltage, you can measure current, and you can also measure the value of the resistor. This is on the left. You can see this is what a typical multimeter is going to look like. But also there are more sophisticated versions. So in some of the lab bench, you will see an equipment similar to the one on the right. It serves the same purpose, but obviously it has more options. And for example, we can see there's still some boards for measuring voltage and resistor, and there's a separate one for current. So if you were to do an experiment in the lab, you will need to keep those concepts in mind. That okay, I need to connect the probe to either the voltage or the current, depending on what I'm measuring. Usually, all of these devices will have like a safety, so hopefully you don't end up doing the wrong thing, but there are usually protections against that kind of mistakes. Um, so if we were to measure the voltage or the resistance of an element in a circuit, what we will do is take the two probes and put them on each side of the element. And we are not interrupting the circuit at all. So we can see here on the circuit on the right, we have a um, we have a battery that's going to provide me with some voltage, and we have this box that can be any element. Let's say it's a resistor. So we put both probes on each side, and we will be measuring the voltage or the resistance of that element, depending on the position we put the multimeter on. There are a few tips to mention here. Is that as you want to measure resistance, is better if you just measure the resistance of your element on its own. Otherwise, what you're going to be looking at is not going to be the resistance of just the element you're looking at, but you're going to be looking at the resistance of this whole circuit. So for example, if you were to measure the resistance of a resistor that is marked as 1 kilo ohm, but that resistance is connected to other part of the circuit, it's very likely that you will see a resistance that is not 1 kilo ohm when you measure the resistor. I'm going to show you some examples later, and there is a hands-on part in this session at the end. When we want to measure current, we want to open the circuit because we want the current to move through our multimeter. For that, now we're opening the circuit and we're putting the probe such that one end is connected to the battery and the other end is connected to the element we're measuring. So that's going to allow the current to circulate through the circuit towards the multimeter and back to the circuit. When you're measuring current, you see we have a red probe and a black probe. Typically, and this is also applied for voltage, is that we want the black one, which is the common probe, to be on usually the negative side of a battery. So that's what we will call the ground. So that if the current is circulating from the battery toward the resistors and back to the ground, we will say that we will expect that the current will be positive. And I think it will make more sense once I show you once you get to play a little bit with the instruments. But don't be afraid that if you see a negative number, either for current or voltage, it just means that whatever you're measuring, your references, it means that either the current is circulating in the opposite direction or that the voltage is positive on the opposite direction. It's not that there is something wrong with your measurement. It's just an orientation thing. Another element that you can find in the lab is that whenever you need to provide any power to your circuits, at first anything is like, oh, I can use a battery, like a AA battery, a 9-volt battery, but you can also use what's called a power supply. The idea of the power supply, they are more stable, they are more controlled, and you can adjust how much you want out of it. For example, I can specify how much voltage I want. I can specify what's the maximum current that I can get out of the power supply to my circuit. So yes, it does work as a battery, but at the same time, you have much more control over certain variables. And this equipment is much more expensive than your average any battery that you will use. So treat them with care if you ever need to use them in the lab. Some other equipment that you find is a function generator. So let's say for any reason you need something that changes over time. So for example, you want something that creates a sinusoid or a square signal for any reason. This will be your equipment to use. Again, this can be very sophisticated. You can adjust multiple parameters. And the only limitation is that if for any reason you want to extract a lot of power, for example, you want to play a tone in a speaker, since these have a very, very limited power, the sound you're going to be able to create is not going to be too loud. At least if you just connect it directly to the function generator. So just keep that in mind. This is usually just for testing. You want to see how your system behaves. You usually later on, depending on the complexity of your circuit, you might be replacing the function generator for something else that's going to create what you end up using. Lastly, we have the oscilloscope. The oscilloscope is going to let you look at signals that change over time. Remember when we first talked about the multimeter? it's usually something that doesn't change because the multimeters just give you one measurement. But if now you have a signal that changes, um, you might want to observe those over a period of time. So that's where the oscilloscope comes very handy. Um, they are much more accurate on their measurements, and depending on the oscilloscope that you're going to be using, you can find them to have 2 channel, 4 channel, or even up to 16 channels, depending on the type and of the oscilloscope. They have these special probes that you're going to be using. Um, so just keep that in mind. It's not just your regular cable. It's a specifically designed probe for the oscilloscope. Okay, I don't know if so far do we have any questions? I think this is the part we're gonna be. It's gonna be more interactive. So um, I will encourage you to participate a little more. Yes. Um, okay. So a very quick exercise. Let's try to look at this example that I have here. Consider the circuit that I have here, where we have a power supply that's going to provide you a 10 volt. DC means it doesn't change. Uh, it's like a battery, basically. And then we have 2 resistors with different resistances. So try to work on these questions that I have here, and I'll give you 5 minutes to write down those. If it's too easy and you think you're already done, like just also let me know so we can move to more the more practical part. Okay, so I'm assuming by now you all are familiar with Microsoft Teams. So once you're done with this calculation, raise your hand so I know that you're done, so we can move on. Okay. All right. I think we're all on. Can I lower your hands? Yes, I can do it. Oh, well, you did it yourself. Perfect. All right. So let's just move more to the interactive part. Um, how many of you haven't used Tinkercad? All right, I'm gonna assume that most of you have used it. So let me share the class code so you can join. Share my screen. Okay. I'm gonna copy the link in the chat. Okay, so I just sent you the link to the Tinkercad, to the classroom. So, and I have created um, accounts for each of you. So use the nickname on the right to log in. Once again, once you're done and in Tinkercad, raise your hand so I know we can move on. All right. So let's see. I'm gonna share with you the link to an exercise I prepared for you. For some reasons. Okay, so what I want you to do is click on the link, and it should show you the option to copy, copy and tinker. So that's gonna let you create a copy of my exercise and add it to your personal account. So you should be able to see something similar to what I have on the screen. I have already created a few elements here. So we have a power supply that is providing 10 volts with a maximum current of 5 amperes. I have created two resistors, R1 and R2, and I also added a multimeter. In this case, is set up for measuring current. So what I want you to do right now is take a minute to, I don't know if you guys have questions or this is the raise hands from before. I suppose it was.
Can you show us how to import the link again? I can't figure it out.
Oh, okay. Yes, absolutely. Can you see the link in the chat?
Yeah.
Okay, so let me copy the link. I don't know if it's gonna let me do it myself since I am the owner.
Like, are you supposed to create a new thing and then press import?
So, well, when you open it, you should see, and you see here it says Tinker this in my screen.
Mm-hmm.
If I remember correctly, I did this early today. You should see another button that says copy and tinker.
Okay.
Unless I didn't set up the.
Oh yeah, I got that.
You got it, perfect.
Yep.
Okay.
Perfect. Thank
So
you.
now you should be able to see it and edit it. So a few things probably you already know. If we go to the right, we have a list of components. By default comes in with the basics. If we click on all, we see the whole list of different components that are available. I have already included a few. We're gonna be playing with some of the other instruments in a later exercise. But for this part, what I want you to try is use the multimeter, connect it to the circuit, and since you already did the calculation in the first part, I want you to, for example, here I'm gonna connect the multimeter, what is it, R1, so I'm gonna connect it between the boards of R1. Also, I am assuming that you guys are familiar with breadboards. Am I wrong assuming that you guys know how to work with them? Okay, I'll take your silence as that you know what you're doing. So I'm just wanting you to like connect them in between. We can go to the button on the upper right, start the simulation, and for example, here we have I connected the negative to the positive side of my power supply and the positive of the multimeter to this middle point. So we see that the voltage that I'm measuring is negative because the current is flowing from the plus towards the circuit and back to the minus terminal. So the current is going towards the right, creating a voltage that is positive towards the left. But since I'm measuring on the opposite position, opposite direction, it's telling me the voltage is negative. So if I were to replace those, we will see that it's the same number, but this time it's just positive. Okay. So try that. You should have the calculation, so you should know what to expect. I will also ask you to measure the current that is passing through. For that, you will need to modify the circuit. Remember that you have to create a open circuit. Okay. I don't know if we have any questions up to this point. No. Okay. I think once again, I'm gonna ask you to raise your hand once you have done the things like measuring voltage and current. I will also encourage you to look at the resistance, measuring resistance, and see what numbers you get. Okay, let's. I think most of you guys have done this part of the exercise. So let's take a look at the resistance. Um, It's not exactly what I was expecting. Okay. Interesting. Apparently, the simulator is a little more intelligent that can't really measure the resistance directly to from the circuit. In real life, you can. The measurement, unfortunately, is not. It's usually not what you're expecting. So, things. All right. Do we have any questions so far? Everything is clear so far. Yes. Okay. I'm gonna share with you another exercise. Okay. Let's take a look at this one. Oh, hold on. But once again, click on the link and add it to your account, so you're able to edit it. Okay. So for this part of I see someone has the hand raised. I don't know if that's a question or was from the previous exercise. Yes? No? David? Oh, okay. All right. For this exercise, I have connected a few elements to the board. So here we have a function generator. We can create different type of functions. For example, we can create a square, sinusoid, triangle signal. We can modify the offset. So if we are looking at adding a fixed component, a DC component, over which the amplitude is going to be moving, fluctuating around, we can add that here. Here we can modify the amplitude. As we can see in the figure on the left, the amplitude is measured from the top of the signal to the bottom. That's what's called the amplitude peak to peak. And we can also change the frequency of the signal that we're creating. So these are going to be signals that are periodic. So they're going to repeat over time. So that's where we can change the frequency. I have added a resistor just for the purpose of the exercise. And this is a small speaker that you can connect, and we're going to be looking at is just playing some sounds. So if you start a simulation, you should. Oh, I forgot I modified the frequency. Here you can play with the frequency. Now I made it more high. We have a 500 hertz. It should be here. It's a little obnoxious, so I'm just not going to keep it running. So what I want you to see is, as I mentioned before, we have the multimeter. With the multimeter, we can look at the voltage. So here right now, the multimeter is connected to the speaker. So you will say, oh, I can look at the voltage. Right now, it's not very useful because it's telling me the volt is 0. Um, Depending on the resolution of your multimeter, if you were to do this in the lab, you might see like a number that fluctuates up and down. So that's not very helpful because this signal is changing over time. So the multimeter is not really providing me any useful information. So let's take a look. This big box here is comes to represent the oscilloscope. You can change the resolution, where I'm going to show you in a minute. So what I want you to do is connect the oscilloscope to your breadboard, and let's take a look at the amplitude on um, the speaker. So one is connected to the negative side, which we normally, depending on the case, we will say is the ground, and the other is connected to the positive wire of the um, um, speaker. So there you go. So that's our signal. The oscilloscope here is gonna auto adjust to the amplitude. So if, for example, here you can also play with the knobs. So if we were to move the knobs to increase the amplitude, you can see that now it says 200 millivolts from top to bottom. So it's changing. It auto adjusts depending on what signal you have. Yeah. There you go. Now it changes to 400 millivolts. So for example, if we were to change the type of signal here, you can also make it a square signal, and the sound that's gonna make is different. Okay, I'm guessing some of you might be trying it, so I'm gonna try not to play for too long. Um, as you work, and this is gonna be well, the oscilloscope here auto adjusts the voltage as you depending on the input, but in a real oscilloscope, you will have a knob that you can move to adjust how much you see, and typically it's gonna say voltage per division. So you can see that this is a grid. So we have 10 squares horizontally, a 10 square vertically. So each of them is going to be a division. Currently, we have it set for the time. So the time is 1 millisecond. So the signal here is 1 millisecond, and there are 10 of them. So on the horizontal axis is going to be 10 milliseconds, and the voltage is just going to auto adjust. So we don't have control over that variable, but if you were to work with the real oscilloscope, you will be able to manipulate the resolution too. So that's something that you will need to keep in mind when working in the lab. Since let's say your signal is very small and your voltage per division is say 200 millivolts um, per division, and your signal is in the range of 10 millivolts, it's very likely you will just see a line, and you will need to adjust the scale so you're able to look at it. Another thing I want to show you, I'm gonna decrease the voltage so it's the sound is not uh, obnoxious. Um, for example, if I were to change the frequency, um, I'm gonna increase it, decrease it. For example, we see now I can barely see one cycle of my signal. This is where the time per divisions is important. So for example, it's a low frequency. So each cycle takes, in this case, 1 over the frequency. So the frequency is 100 hertz. That means they're going to be 100 cycles per second. So if I take the 1 over 100, that's going to tell me, oh, each cycle is 10 milliseconds. And that is exactly what I have here. So we can see here is a full cycle of my signal. So if I want to see more, let's say, okay, I want to see 2 cycles. Well, actually, that's not very helpful. There. If I want to see more cycles of my signals now, time per division is 2. So now we see more cycles. So depending on the nature of your signal, you might want to adjust those knobs to be able to visualize it correctly. Because, for example, if I increase this too much, this is something that can happen in the lab. You just see like a big um, piece of signal that is not, you can't really see what's happening. So that's when you have to decrease your time per division to be able to visualize it correctly. Well, those are mostly the exercises I have prepared for you. I wasn't really sure how much I needed to prepare for. Apparently, I underestimate the time, so we have some extra time. I don't know if you have questions, or I don't know if any of you are working in a specific project related to that requires you to use breadboards and instruments, or if you are here just for pure curiosity. Um, there are a few options. You cannot really recreate every circuit, but the selection that you have here is very broad. So you might be able to find most of the components that can help you simulate circuits. Unfortunately, not everything is here, but I think it's if you're working remotely and don't don't have access to a lab, this is a very good starting point. Obviously, though these instruments are not exactly the same. An oscilloscope, as I showed you before, has multiple knobs, and there are more settings that you need to play around to be able to visualize. As a tip, if you're ever in the lab working with oscilloscope, there is usually a button that says auto that's gonna find the best settings for to visualize your signal both in times and amplitude. So usually, if you're kind of lost and can't see what you're looking for, that's usually a very good starting point. And from there, you can start adjusting to see what you want. Auto is not always, it's not a solution to everything, but it's a very good starting point. Well, I don't know if you guys have any particular question. It can be like a little bit beyond what I cover, and also knowing your feedback is going to be very valuable, so we can prepare for the next part of the series. If you think, oh, that was too basic, I would like to see something more, or if you want us to like take more time to explain some concept, that's also very helpful. So any feedback you guys have, just please let me know. You don't need to do it now. You can, if you want, you can send me an email later on, since I'm still recording the lecture. So I don't know. I'm just gonna open it. I'm gonna keep it going for probably 5 more minutes, in case you guys have questions, and we can work on those. Again, I'm just gonna keep this going for a few more minutes, but well, thank you for coming, and again, let me know if you have any questions. Feel free to either ask here or in the chat, or just send me an email. And if you're working in your electrical related project, just let me know. I mean, I know the content here is very basic, but there are more things that I might be able to help with.